Hi guys, welcome to my world of physics infinity. Another challenging problem, tricky problem on ray optics. Here you are. There is a equiconvex glass lens kept in air. Its focal length is 10 centimeter. On face value, this will appear to be such a simple problem, but when you start tackling it, you will find, well, there is a clue, there is some trouble. Now the same lens in a different scene, in a case 2, if we have air on its left side and water on its right side, of course it's a glass lens, but now the medium on the either side are different. Air on the left and water on the right side. What is its focal length now? If, and two cases for that. If the ray is hitting the lens from the air side, or if the ray is hitting the lens from the water side, the focal length will be different. In air it is 10 centimeter given. So let's start. First of all, I use the knowledge of its focal length in air to be 10 centimeter. Well, I make use of the good old lens maker formula. Equiconvex lens means what? The two curvatures, radii of curvatures are same. Okay, let me take it as R. So I find R using the lens maker. Glass lens kept in air. Glass lens kept in air. So 1 by F is Ng difference Na upon Na into 1 by R plus 1 by R. Put the values. Ng is 3 by 2. So that gives me R as 10 centimeter. Focal length in air is 10 centimeter and the radii of both surfaces also 10 centimeter. Keep it. I'll need it now. Now let me take the second case where the ray is hitting the lens from the air side. Now the focus will be in water because the ray will come from here, pass through the lens and get focus somewhere on the principal axis at the principal focus, and that would, the focus I can say would lie in water. Now for that I give you a very interesting formula. You don't have a lens maker formula. You don't have a lens maker formula when there are two media involved in which the lens is kept. Now there are three media involved: air, glass, water. In the previous case, first case, it was okay because on the either side there was air. But now it's not air on the either side. There is air on the left side and water on the right side. So there you are. I can't use lens maker. So what do? Oh, here you are. I take a rabbit out of my hat. I give the formula. If the focus is in water, then it is NW by F is equal to, well, the power of the two curvatures. The power of the two curvatures is same. Difference of refractive indices divided by R. So Na difference Ng by R plus Na difference Nw by R. I put the values of Na, Ng, Nw and R. I get the answer 20 centimeter. So now the focal length is 20 centimeter. Let's go to the case 3. Now the ray is hitting the lens from the water side. Is hitting the lens from the water side. So the focus will be in air. So there you are. So Na upon F is the sum of the two powers of the curvatures, curved surfaces. So this is Na. This will be Na. Of course, I've written N. No, it's not N. This will be, of course, Na. So Na difference Nw upon R plus Na. Difference of Na and Ng upon R. I put the figures. The focal length comes out to be 15 centimeter. Beautiful. Now here I tell you something more interesting. Whenever you get stuck in the problems of physics, and especially I'm talking at the advanced level, because they will not give you straightforward problems with the application of formulae and you get the answer. You know that. Remember, your savior are the basics. Now, what is the basic issue here? The basic issue is here, think of the definition of principal focus. The principal focus of a lens is that point on the principal axis where rays incident on the lens parallel to p-axis meet or appear to meet. If they meet, it's a real focus. If they appear to meet, it's a virtual focus. You could do this problem. Now, this is a clue I am giving to you by solving this problem by the first principles. So, what you do in the first case is okay, R you have found. So, in the second, when the ray is hitting, so take rays parallel to p-axis from the air side, while do the refraction formulae for the first surface, for the second surface, and find the final image. Well, the final image is the focus. You'll get the answer 20. And now do the same thing. Strike the lens from the water side, and the ray should be parallel to p-axis. Parallel to p-axis. Well, use the refraction formula for curved surface for the water glass and then glass air. Do it. Do that as an interesting exercise and check your answers. You'll get the same answers as 20 for the second case and 15 for the third case. Well, you must have really enjoyed this video. Do subscribe my channel. Put a thumbs up for my videos.
If you love the video and want me to make more useful videos for you, subscribe my channel and hit the bell icon to stay updated.